Okay, so now we're going to talk about section 10.3, graphical solution in Math 110. In order to have a linear programming problem, we must have constraints represented as inequalities. And another thing is an objective functions, that is a function whose value we either want to be a large or large as possible, or what we call is maximize, or as small as possible. Uh, in another word, we want to minimize. Okay, so let's move to the next page. We have 6 steps to solve a linear programming problem graphically. So the first one is define the variable to be optimized, such as like A, B, C, what is that gonna be? Okay, um, and usually we're gonna check by the question asked is good indicator as to what these will be, right? Number two, write the objective function first in words, then convert to a mathematical equation, and then write the constraints first in word, then convert to mathematical inequalities. And step number 4, grab the constraint inequalities and shade the feasible region. And number 5, identify the corner points by solving system of linear equations whose intersections represents a corner point. And the last step, number 6, test all corner in objective function. The winning points is the point that optimize the objective function. So the big S if we want to maximizing, and small s if we want to minimizing. Okay, let's do an example here. So, example with product assembly. A company produces a basic and premium version of its product. The basic version requires 20 minutes of assembly and 15 minutes of painting. The premium version requires 30 minutes of assembly and 30 minutes of painting. Assume the company has staffing for 3,900 minutes of assembly and 3,200 minutes of painting each week. They sell the basic product for a profit of $30 and the premium products for a profit of $40. Okay, so how many of each version should be produced to maximize profit? So the question in here is how many each version, right, should be produced to maximize, and we want to maximize the profit, right? Um, so so we need to know what is version in here. We have basic version and we have premium version, right? Um, so uh, let's say A. No, let me see. B. Let's say B is number of um, number of um, item that basics version produce, right? Um, and P is number of items that's premium version produced, right? Um, so so uh, so we want we want to, so this is step one, because step one say, in here, step one say define the variables to be optimized. And we did use a question to indicate to what these will be. Okay. So now the second one say write the objective function. Okay. So objective function. Objective function is we want to maximize the profit, right? We want to maximize profit. So let's say P, big P is profit, will be equal to the profit. It is like the profit of the basic product and add with the profit from the premium product. So so I have basic product will be $30 for each item, right? So $30 times B plus with $40 times P for each item, right? So that should be the profit function, and we want to maximize it. Okay. Now let's see what is the next step. Okay, so we want to write the constant of and first in word, then convert to the mathematical inequalities. So now we need to do the constant. Okay. So constant here is objective. Objective. Let me see. Okay, and constant gonna be, I use it as a color. Okay, so for the objective, I need firstly I need the basic version require 20 minutes, um, and the premium version require 30 minutes. So assembly. Okay, so in here it says assume the company has staffing for 3,900 minutes of assembly. So what does that mean? So company has staffing for 3,900 minutes of assembly. So I'm gonna write as I write that firstly is the basic version is 20 minutes. So 20 minutes 20 minutes multiplied by P, because it's from the basic, right? And plus with 30 minutes for premium. So 30 minutes for premium. So P. And staffing for 3,900 minutes. So this equation should be less than or equal to 3,900. Okay. That is the first constant. The second one say the second one say company has staffing for 3,300 minutes painting. Okay. So I'm gonna use 15 minutes of painting for the basic requirement. So 15B plus with 30 minutes of painting for P. So 30P, and it should be less than or equal to 3,300. And that should be the second constant. Okay. And so we're done with the third step. What is fourth step? Okay. I have the fourth step say graph the constant, graph the constant inequities and shade the visible reason. Okay. So similarly with graphing linear inequity system. In here we have so let's see. Okay, so the system should be 20B plus 30P less than or equal to 3,900. And the other one is 15B plus 30P less than or equal to 3,300. And you should also know that B should be greater than or equal to 0, and Q and P should also greater than or equal to 0, since it's like a real life problem. Okay, so we try to figure out um, the best number for B and P. So then later we're gonna maximize the profit. Okay, so firstly I need to find the feasible region with a solution for all of this linear inequity system. So follow all the steps from the previous session 10.2. We will need to draw a rectangular first. Okay, so let me use line here. Okay. Okay. So firstly, let me use 2T table so we can later easily draw it. Okay, so first one is for B. Oops. Oh wait, I have to change it to be the um, change it to be the slope intercept form. So let's use B, isolate B first. So I'm gonna have 20B. Oops. 20B less than minus for 30P both inside. So I have 3 minus for 30P and then plus with 3,900. And then the second one should be like 15b less than or equal to negative 30p, and then plus with 3300. And then we also know that p should be greater than 0, p is greater than or equal to 0. Actually, you know what? We're gonna it's okay. So we need to divide both sides by 20, right? So b now gonna be less than or equal to negative 3/2 p, and then plus with 3/900 divided by 20. So 3/900 divided by 20 and 195. This is exactly the problem before that we did. So let's just redo it to make sure. Yeah, so exactly the problem in 10.2, right? So the second one gonna be b less than or equal to negative 2p divided by 15 both inside. So 300 divided by 15 have 220, and then b greater than 0, p greater than 0. Okay, so now for the first one, if I say p equal to 0, then b if I put it equal to negative 3/2 p plus 195, then I'm gonna have b equal to 195, right? And if it's equal to say 10, then 10, then what happened? Ten, and then the answer for b should be let me see. So 10 divided by 2, 3 gonna be 15, negative 15 plus 195. So it's gonna be negative 180. So 180, and come on, what happened? Okay, and then the second one, I have p and b equal to negative 2p plus 220. So here is 0 and 220, and here is 10. You're going to have 200. Okay. So use answer color. The first one have 0 and 195. So 0 that I use here is so 20, 40. So here's 100. 200, 220. So here is the first point for the second equation, and the first point for the intercept of the first equation gonna be 0, 1, 95. So is here. Second one gonna be so say here is 10 here, and I have 10 and 180. 180 is here. Maybe I use as a color. The second one is 10 and 200. 10 and 200. Okay. Now let's gonna draw it. Okay, that is for the first equation. The second one, okay, this is the second one, right? And as we know from the previous solution, we know that the feasible region is going to be the area, the area solution area. So I will have the solution area will be the red one over here. The area under both of this. Okay. And make sure, because we just take P and B greater than 0, then we don't want to take the one less under the X and Y axis. Okay, so that should be the feasible region. All right. Now what do we have? Okay, so let me say notate that is feasible feasible region. Okay. So this is exactly the step 4, I believe. Let's move up a little bit. Okay, so the number 4 say grab the constraint increase and shade of feasible region, and then number 5, identify the corner point by solving system of linear equation whose intersection represent a corner point. Okay, so we need to solve the corner point for this system. So for the region, right? So what is the corner point that's in here? Let me show you guys. Okay, so it is this one. We also the let me see. Oops. Okay. Oops. All right, better. All right. So the corner point is this one corner point. This one, the intersection one, and this one, which is x-intercept, and the last one gonna be 0, 0, origin. So this for we have totally 4 corner point, right? In step 5, we have 4 corner point. So the first one is 0, 200, because this is the y-intercept of the sec. No, this is not 200. Sorry, it is this should be 295. Yep, 295. Sorry, almost messed up with it. 195. Sorry, 195. This is 195. 0, 195. Because this is the the second no, the first equation, b equal to negative 3 half p plus 195, right? And and the the point at the bottom here should be the x-intercept of the second one. So we mean if I put b equals 0 in here and 5p, and I'm gonna have that number. So I will let's use this one, or I can even use this one. That's fine too. But let's just use this one. So if I put b equals 0, so I have 0. Let solve the equation, right? I have 0 equal to negative 2p plus 220. Then I have p will be equal to negative 220 divided by 2, negative 2, which equal to 110. Okay, so the second one is x-intercept of the second equation, b equal to negative 2p plus 220, gonna be 110, comma 0. That is the second corner point. The down the origin one should be 0, 0. Everyone should know, right? The only one in here is the intersection one. We need to solve the system equation. So we need to solve system equation as b equal to negative 3 half p plus 195, and then b equal to negative 2p plus 220. Okay. This should be a little bit long if we use only this page. So I would like to have a small side here, a sidewalk here. Let's see. So I have I can substitute. I'm gonna substitute the second one into the first one. So I have negative 2p plus 220 equal to negative 3 over 2p plus 195, right? So then now you will have uh, okay, so we're gonna add both hand side by 3 half p. Okay, 3 half p both hand side. Then the right hand side now just have 145. The left hand side will have 2p plus with no, just say 4 negative 4 plus 3 half, negative 4 half plus 3 half will be negative 1 half. So negative 1 half p plus 220. And then I will subtract both hand side by 220. Okay, and now now I'm gonna have left hand side, right hand side will be 5 2 minus 7, and then so it's gonna be negative 75 and negative 1 negative p over 2 equal to negative 75. And if you multiply both sides by negative 2, you will have p equal to 0 150. Okay, so that's going to be p equal to 150, and then substitute p into b into any equation here. You will have b equal to negative 2 times 150 plus 220. So negative negative no, that's something wrong. Yes, something was wrong here. I actually noted that it should be 195 here, but I wrote down wrong as 145. So 195. And then 195 here minus 220. Now it's going to become negative 25. And then multiplied by 2, negative 2 going to be 50. And then b will be negative 2 times 50 plus 220. Okay, now it makes sense. So I have negative 100 plus 220, so that's going to be 120. Okay, so b is going to be 120 and p is going to be 50. So so this guy will be 50 comma 120. Okay, so another one is 50 and 120. Okay, Thanks God. Okay, now what we need to do for this problem is we need to substitute and compare all the substitute all these value corner into the subject subject object function, and which one give us the maximum gonna be the answer. So what is an objective function? Let's move up to C. So objective function is 30b plus 40p. Okay, so 30b plus 40p. Okay. So let me delete the area down here, so we can substitute, right? And also I may gonna delete the area in the top with the T table, so later on we can have more space to work on this problem. Okay. Okay. Let me make sure I have 30p and 30b and 40p. Okay, 30b and 40p. Just wanna make sure. So 30. So objective function is 30b plus 40p, right? And we want to maximize this. So p equal to this, right? So now let's try, let's test say test 0, 195 first. Okay, let's see. So I have p will be equal to 30. Remember that's 190, 0. The first is p and the second is b. Okay, so don't mess up with that. So 30 times with 195 plus 40 times 0. So I will have p will be equal to so 30 times 195. So that's going to be 5,800. 5,850. That is the first one. Okay. So I'm gonna test the second one. The second one is 1, 1, 0, and 0. So the P will be 30 times 0 plus 40 times 110. So in this case, P will be equal to, so use the calculator again. Yeah, 40 multiply by 110, and then I have 400, 4,400. Okay. So let's test this. The third one is 0, 0. Actually, you don't need to test this because that should not be, and that should not give you anything. That should give you right away p equals 0. So you don't have to worry about that because we want to maximize it. So we're going to test. The last one is 50, 120. So that's going to give me p equal to 30 times 120 plus 40 times 50. Okay, don't mess up with the position of B and P in here, okay? So now you will have P in this case will be, so use calculator. Okay, so I have 30 times 120 plus 40 times 50, and you will have 5,600. 5,600. So compare all of the solution, no, all of the P for each corner of the feasible region. I know that the P max, so P max is 5,850 at B equal to 195 and P equal to 0. Okay, so that will be the maximum for P, and that's also going to be the solution of this problem. Let me see. Okay. So let me gonna minimize this one. Okay. So you can go ahead and take a picture of these, or pause my video and write that for this solution. Okay. This one is one of the hard one in this class, and I hope that you guys can handle it, because this even though this is a hard one, but it's really useful in the marketing, I mean in the business or the finance class. So I hope and I expect that could be one of the problem in the final exam. Okay. So now let's move down to the next page, and I actually finished section 10.3. So we're gonna do the 10.4 later, and I will stop this section.